Hey Jody, here with weldingtipsandtricks.com. I'm still working on this aluminum intake manifold. This is for a 280Z. It's an inline 6. And I made some progress on it, so that's what we're going to show today. Welding with a couple of different welding machines, different settings, some thick to thin, some thin to thin, that sort of thing. The fuel rail bungs here, I've got a fixture that's going to line those up, so I'll probably have to cut a few of those and move them around. Getting pretty close to wrapping this thing up, so let's get into it. Alright, this is where we left off with the part 1 video. Got everything tacked up, the main part of it anyway here, and got one side of the flanges welded, and I used the Everlast 255 EXT for that. Had the machine set on 225 amps. You rarely needed all that, most of that was under 200. 77 hertz on the AC frequency and 31% cleaning action. I was using a 75-25 argon helium mix, 25% helium, 75% argon. Made for a nice clean puddle and 77 hertz puddle immediately. This is on the actual part here. Thick to thin, you kind of have to favor the thick part a little bit, but you can see it's a fairly clean puddle. Even though I cleaned it really well, it had some previous tack welds and stuff that weren't quite ground off on it, and so again, there was some stuff floating around in the puddle here and there, but relatively speaking, a very clean puddle that moved along really well, and I really like that. I always like to get a nice clean puddle as opposed to more penetration and pepper in the puddle. So I'm going to go to the Dynasty 280DX here. I'm going to be using advanced square wave on that, just so I'm keeping everything kind of apples and apples here. And you can adjust. There are several different waveforms in here, and I'll go over that in a future video. I'm going to set the amperage the same, and everything else the same as well, frequency and cleaning. Now, I don't have a cooler hooked up to the Dynasty yet, so I have to use this air-cooled torch. And I decided to use this flex lock from CK with this big gas lens on it to kind of conduct some heat and hold up a little bit better. It's only a 150 amp torch, and I'm going to be using around 200 amps here. And so the torch got pretty dang hot. But one thing I noticed right away is the puddle was just not as clean. And didn't really know why. I thought maybe the base plate wasn't cleaned as well as I thought it was, but just wasn't quite as clean as I would like to have the puddle, even though I have the settings set all the same. And I really kind of think that I have a small leak somewhere either in the torch fittings or somewhere, because here's the way that puddle looked. Just some oxide films floating around. You see the bottom plate. Even though I cleaned it with chemical aluminum cleaner and a Scotch-Brite pad and then acetoned it really well, it's just got some oxides floating around in the puddle that I don't really like to see. It did the job okay, but I'm going to swap torches, not quite yet, but in a minute I'm going to swap torches and see if I can get to the root of that problem. Right now though, I'm going to go ahead and, it's welding good enough that I'm going to go ahead and tack weld this little sheet metal split tube for the top of it. And I'm just going to clamp it down and get a place that matches up, clamp it down against the flat surface. You can see there's some gaps there, so it's not really a perfect cut. I'm going to have to deal with that later, but I'm just kind of using those clamps alternately to massage it and get the high-low, the mismatch out of it, and get several tacks on it so that I can get it tacked up here. I had to get it to this point so I could take it to the guy kind of for a kind of a buy-off on it before I went further. And also to get this piece of sheet metal from him. This is 16 gauge, so it's 0.63 thickness, and I've got a little bit of work to do to make it fit up as good as I can. And originally he was going to go with this tread plate, and he decided to go with the smooth. I'm kind of glad he did. I think it's going to probably look better with the smooth. But since I've got that tread plate, I decided to go ahead and see if I can swap torches and make a clean weld. So I set it down to 100 amps here, still balance on 69 just like before, but I adjusted the frequency to 100, and we're going to get a little quick tack weld on here and then do a little bit of welding on the sheet metal just to see. Now I've swapped torches. I'm using a different cup, mainly just for filming purposes, but right away, nice clean puddle. And I think I'm going to have to really prove it out on something else, but I think I have a small leak in that flex lock somewhere, flex lock torch, I'm not sure, but all I know is this is welding a whole lot cleaner without changing a whole lot. You can see the etching zone kind of extending out like it's supposed to outside the bead. The puddle is nice and shiny and wet and clean and moves along really easily. And so this is a 150 amp torch as well with a valve on it, even though I don't need the valve. But it's doing pretty well. I just decided I might as well film this since I was trying to figure out my problem. Probably not a good idea to change so many things. I changed torches, I changed cups and everything, so I'm gonna have to go back and try to figure out what the issue was exactly. But this is a Pyrex cup. I don't use them normally for just everything, but it is good for filming for me, and it does let you see all the way up inside and see the tungsten. And if it's remaining silver, you know you're at least not in too bad a shape on your argon shielding gas. All right, so let's move on now. Alright, so I'm swapping back to this machine. This is sent to me for testing and evaluation. So I'm testing and evaluating it here. And I'm changing the amperage down to about 100. And I'm going to change a few settings. The AC balance, I'm going to leave at 31% cleaning. Notice that that's backwards from what the Dynasty is. The Dynasty reads 69% EN. This is actually reading the electrode positive portion. And I'm setting the start amperage up around 20. And had a few little stutters on the start on this machine, so I'm just kind of experimenting with the start amperage. I'm not really sure it's even doing anything. But first thing I've got to do is sand this thing off. Get a nice smooth straight edge here, as straight as possible. I'm not going to try to get it perfectly straight because I'm going to scribe a line anyway. Here I'm just deburring using the Leatherman tool, making sure I don't have any burrs on the inside. I'm going to clamp this piece of 063, that's 1.6 millimeter thick sheet metal, just leaving just enough room for a weld, about 1/8 of an inch, 3 millimeters roughly, and I'm going to scribe a line here with the pocket knife part of the Leatherman, and I cut that using just a cutting wheel with a 4.5-inch grinder, and clean it up with a disc sander. And I'm giving a good acetone wipe on everything, all the welded surfaces, get all the tape residue and all the gunk off of it. And I got to get a lot of tacks, which is very common for sheet metal like this. If you don't get a lot of tacks, it will buck, and you'll get mismatch as you're welding. Sometimes it'll overlap, and it's good to have a lot of tacks. Now I'm welding 1/2 inch thick to 1/16 inch thick, and that poses a little bit of a problem if you're not careful. So I'm going to show really quickly how I do that. And basically it is just lighting up on the thick part, preheating it a little bit, and then kind of stabbing the rod to join the two pieces. So the thick part's on the bottom, it's 1/2 inch thick, and I'm just going to soak it with heat for just a few seconds. You see the top part is wanting to puddle very easily. As soon as I get the bottom piece to puddle a little bit, just stab a little rod in there and get the pieces to join. Now once they're joined, they'll conduct heat more evenly, and then the thin piece won't peel back nearly as easily. So that's kind of how that goes. Once you get used to it, it's a lot faster, and you can almost sometimes just blast it and get rod in there too. But if you're not used to that, it's better to sneak up on it like that. Now, what I'm doing here, I know this looks really ugly. Had a lot of tacks, but as I was welding this thing, I could tell it was opening up, trying to keyhole with me, and I'm having a jam rod in to fill the holes, and it was making it very uneven. So what I did is I ran a very small cold bead. It looks really ugly, but it's got everything joined together, so then I can come back over it and not worry about holes opening up and things like that. So it's making something that was going to look pretty bad look a whole lot better. And minimal heat, just enough to put a little bead in there, then let it cool, then come back over it, and you can really sink the heat in there and make nice smooth penetration on the backside. A lot more than you can with gap, where it'll try to keyhole and be all uneven. Now this is a much better fit here, so I'm not having to do that, and it's coming out okay. The arc you're listening to right now, again, is that Everlast 255 EXT, about 100 hertz, 31% cleaning action. And this is a whole different torch setup. Notice it doesn't have the valve on it, but I'm using that same number 8 Pyrex cup. Mainly, like I said, just because it kind of seems to illuminate the whole area and makes for better filming. I could almost make this whole run if I didn't run out of rod, if I wasn't filming and weren't
stop and get different angles. I could make this whole run without stopping, which is kind of what you want to do if you can. A lot of times, not always. Sometimes you want to stop, position, change the heat, sequence the feed differently. But you know, being able to drag a TIG finger along a nice smooth aluminum surface like that really helps a whole bunch. I'm getting ready to weld around this thing now, and what you need to have in mind here is rotating the torch. Each time you come out of the puddle with that rod, basically, you need to, in your mind, rotate the torch a little bit. Otherwise, you get too much torch angle really quickly on a round part. It's worse with small diameter stuff. So just keep it in mind. If you don't keep it in mind, it's easy to get out of scope. But if you keep it in mind, every dip to kind of rotate, clock the torch around, and kind of aim for the center of the tube and pipe, it really helps things go a whole lot better. Flex head torch really comes in handy. So I'm going to bend it a little bit. It helps me keep the right angle. You can see I can just prop my TIG finger there where there's no great place to prop. And I can just kind of twist my wrist around without my finger cooking and make the weld a whole lot better than I could without it.
All right, well that about wraps it up for this week. An aluminum part like this gets hot really quick. Hard to find a place to prop. You can find a place you can cut 4x4 wood and use that for propping on and things like that, but a TIG finger will help you make a nice long run without stopping, and it glides along a smooth surface like this. I've got the TIG finger and the TIG finger XL. XL is big enough for most people to put 2 fingers in, and it's thicker and more heat resistant. I didn't really need the XL for this job. I used the regular for the whole thing. I was able to make nice long runs and was able to find a place to prop no matter how I position this thing. Hope you could see that. Didn't intend for this to be a TIG finger commercial really, but I guess it is. So anyway, hope you got something out of it. We'll see you next time.